This is the one, right? Okay. I think we have everything set up. The lecture notes here too. Nice. So, okay, I'll drink some water and then I'll get started. 3 hours, although we'll only be able to do 2 now. Maybe like 2.5, we'll see. Really just depends on how things go. Maybe we won't need the 3 hours though, but we'll see. Alright, screw this in. My water bottle, that is. Alright. So, not all of this will be stuff I can actually write into here because matrices, but I will do my best to show what I can. I wonder if I should like snipping tool out like the questions I'm doing. Might be easier that way, because then what we can do is we can just have the Word doc up and this on the side. Whee! Oh, I can rate that matrix. Yeah, right. We'll see how this goes. Oh, actually, we need to put this like here, and then when I do this, why is it so small? It's so teeny. If it looks tiny, la la la. Okay, no, it's just the default text. See, this always takes forever to load, so maybe I should like get it loaded so that if we need to use it some more, I can actually use it. I wonder if the max is 3x3. Then do I have to load it every single time? No, first time load. Okay. Oh, matrices with brackets. Oh, sparse matrices. Oh, okay. Yeah, I've never looked into it very much. A lot of the matrices I usually just draw them or write them up. When I'm doing matrix operations, I'm definitely gonna have to write stuff. I'm not gonna do that. I'm gonna do that by hand, not through here. Although we'll probably put it into a calculator online to check our results. If anyone else wants to do it. I don't know why you would, but in case. Okay, so I think I'm just gonna get started now. The 3-hour exam, so yeah, let's do this. Our initial matrix is what? Okay. I'm trying to. No, it's because live split is gonna. Let me tab everything over first. Okay, so now we have this one and the exam one and the snipping tool thing. 1, 1, minus 1, 2. 3x3. 1, 1, minus 1. 2, 0, minus 1. 1, minus 2, 1. It's so hot right now. I feel like I'm getting itchy. It's a bit irritating. So I'll be right there. Okay. I don't know if that's like technically the right way to put the line there, but whatever. Probably not. Let's use this one here. There we go. And this one is no wait. They want ax equals b anyway. So we are not writing it like that. No, don't tell me I can't get rid of the line now, man. Okay, back. There we go. And now we can insert this one. I'm just gonna, since we're gonna need to use this anyway, copy that. X1, X2, X3. What was it? 2, 1, minus 4. 2, 1, minus 4. Yo, Mouse! Hey! Yo, by the way, thank you so much for the sub. Thank you for the support. Thank you also for the gift sub. Like, you are so sneaky. But, like, I see him and it's like, Grr. Thank you for being so kind and generous. It means a huge amount to me. Lots of love. Lots and lots of love. X equals this one, obviously. I'm sure this is like common sense, but I'm just gonna write it here to be clear. I'm gonna tap them over from each other as well. Alright. Calculated sum of A. Explain how the value. Okay, gotcha. Okay. D. B. I wish I was that far in. Okay. Cool. Dead A. Equals. How am I gonna do this? Dang, I'm gonna have to write 2x2s, hey. Let me get 2x2s ready. Then you do this. Boom. Boom. Oh. Well, it's okay, I can paste stuff anyway. So this is what? 1, 0, minus 1, minus 2, 1. Expanding about the first row. Actually, this is the wrong size. How do I... I'm forgetting my shortcuts. How do you size down? Is it Control Shift down? Control. Oh my gosh. How did I forget? Don't know what it is now. Oh, it's Control Shift less than or more than. Like it's become habit at this point, but then when I need to think about it, it's like, no, of course you don't remember, Yoshi. That's silly. Why would you remember? Plus? No, it's minus. And then we have 1, 2, 1, minus 1, 1. Yep. And then take 1, because it's negative. You get 2, 0, 1, minus 2. Okay. Sure. And this is 0, take 2, take 1. 2 plus 1, take 1. Minus 4 plus 0. Take 0. Whatever. Equals. So this is what, minus 2, take 3, take minus 4 plus 5. 4 equals minus 1. Okay. I hope that's right. Just gotta double check this now. 0, minus 1, minus 2, 1. I did write this correctly, right? I should probably check that first. 1, 1, minus 1, 2. 2, 0, minus 1, 1. 1, 2, minus 2, 1, minus 4. Okay, got it. And then I wrote this the same. Yeah, it's copy pasted, so there's no way. 0, minus 1, minus 2, 1. Take 1, 2, minus 1, 1, 1. 2, 1. 0, minus 2. We have a negative 1 here. Then it's 0, take 2, take 1. 2 plus 1, take 1. Minus 4, take 0. Yep. Minus 2, take 3. Plus 4 equals minus 1. 6 hours until I have to get out of work, so I won't be staying this time. Have a good day, Sayush. Thank you very much, Mouse. Have a good night. Sleep well. You definitely need to sleep well. Okay, so since that A is no, it's, I think it's, no, is it not? Not equals? What was it? No, I'm doing the wrong one. There we go. I should know that. Alright, not equal 0. A inverse exists. Nusu, hello. Oh man, linear algebra. You have experience? You're Nate, welcome. Welcome. Good luck, thank you, thank you. See, using row operations on the augmented matrix, find the inverse of A. Actually, I like using the other method. Maybe I should do it. It looks simpler now, I feel. I should learn how to do both, right? I mean, I know how to do both, but it's like, do I want to do the other method? I'll do the setup matrix here. I'll write the setup matrix just so that we're clear on what I'm trying to do now. That comma is not okay. Nice. Oh, that's inside. No, I want this to be here. No. Hello. Oh, can I not like do anything? Oh, because the brackets, right? Hold on. Let me think. Can I highlight just the inside? Yes, I want that. And then this bracket is not inside. Boof. And then we'll put the identity matrix on the other side. Oh, you know what? We can do this. 1, 1, 1, 0, 0, 0, 0, 0, 0. Hello? You're part of bracket. You are part of bracket. It is not. Can you? I'm very sad. You could just pretend it works. This is why I do this part by hand. Anyway, we're gonna row reduce. Row reducing the left side of the. Oh, you know what? I'm not using square brackets. That's a problem. Even oh, it's because it copied the bracket over as well. Here, hold on. So if I X that, and then it doesn't close bracket properly. Copy and paste the right bracket again. Can I? But then I can't like do stuff on this side. Man. No. Stop me from pursuing computer graphics? That's fair enough. It's definitely tricky. I can only imagine it'd get worse, but hey, I've reached the end of the course for now, so we just have to revise for exams. We'll see how this goes. Okay, I'm gonna try and row reduce left side of the matrix. Following matrix. Alright, let's do it. Bookwork time. You can pretend it's square brackets. I know I messed up. 2, 0, minus 1. 1, minus 2, 1. I don't usually use this method. I usually use the cofactor matrix method, but we'll see how this goes. I'll write my steps here so you guys can follow, I guess. What should we do? Okay, I think I'll go R3, take R2. Nope, that's not capitalized. R3. R2 become R3. So now we're gonna get 1, 1, minus 1, 2, 0, minus 1. You get 0. Minus 3, 2, 1, 0, 0, 0, 1, 0. It's 0 minus 1 1. Okay. Now, would we reduce? Thinking. You have a 0 there though. What am I doing? Oh, I can restore pivot to second row if I R2 take R1. That'll give us a simpler second row, I think. Right, so we go 1 1 minus 1. 0 minus 3, 2 at the bottom there. One minus 1 0. Okay. I think that's easier to work with now. Just checking my calculations. Alright. 1 0 0. 0 minus 1, 1. Since you're doing R2 take R1, you have to take it minus 1 1 0. Okay. So that's the next step. Next. Interesting. If I do R1 take R2, or should I add R2? No, I should take R2. I want to take R2 to get R1. Right, and that'll give us 0, 2, minus 1, 1 minus 1, 0, 0 minus 3, 2. 2 minus 1, 0, minus 1, 1, 0, 0 minus 1, 1. Okay. So now R1 and R3 have zeros. That means we're gonna have to have row 2 swap with row 1 at some point. That's okay. We'll figure it out. What do we reduce next? Multiply row 1 by 2, add it to two times R1. Should I add it? Plus R2, yeah. That will give us R3, sorry. That gives us what? It doesn't matter actually. Let's make that R1. Alright, then we got 0. 4 take 3 is 1. Oh, that's better than I thought. 0, 1. 0. Minus 1, 1, 0. 0, minus 3, 2. Then we get 2 R1, so that's 4. 4 plus 0 is 4. Minus 2. Take 3. Take 1 is minus 3. 0 plus 2 times 0 is 0. Plus 1 is 1. Right? Yeah, minus 1, 1, 0. Is 0, minus 1, 1 here. Okay, so next step is 2R1 plus R3 equals, or becomes, R1. That operation is for R1. Cool. Okay, and at this point we actually have a pivot in the second. Ooh, this is loud music. How much do I need to turn this one down? Jeez. You're very loud. So I want to swap R1 and R2 now. This will give us minus 1, 1, 0, 0, 1, 0, 0, minus 3, 2. And then you get minus 1, 1, 0, 4, minus 3, 1, 0, minus 1, 1. Epic. Right? So we're going to... How do I do multi-sided? I don't know how to do it. I don't actually know. If anyone knows, let me know. I'm curious. So we can now use that to subtract R1. Oh, yeah, okay. This is easy now. We go R1, negative R1, so that we can get 1 in the first. We get negative R1 plus R2 becomes R1. You can also then reduce the third row. So you can go R3, R2 plus R3 will become R3. Cool. Okay, so next up, minus R1 plus R2 is going to become R1. We also have 3R2 plus R3 becomes R3. Could write them as separate steps, but I'm just showing that I did them in the same step. Okay, so 1, 0, 0, 0, 1, 0, and the bottom becomes 0, 0, 2. Yeah? 0, 0, 2. Then the right side is what? 1 plus 4 is 5. Minus 1 take 3 is minus 4. 0 plus 1 is 1. Okay, and this remains as 4 minus 3, 1. And then you have 3R2, so that's 12. 12 plus 0 is 12. Minus 9 take 1 is minus 10. And 3 plus 1 is 4. Right? And then now all we have to do is divide, well, half times R3 is now R3. Okay, and I'm just gonna do that quickly. 0, 1, 0, 0, 0, 1. 5 minus 4, 1, 4 minus 3, 1, and 6 minus 5, 2, and that is our inverse matrix. Hopefully. Hopefully is our inverse matrix. Otherwise I'm gonna cry. Let's see here. A half. 2 times R3 equal. No. What? I'm looking at the wrong step. There we go. That will become R3. Right, so our final matrix. You know what? I'm just gonna do my 3 by 3. Then let me do this, and then use the other 3 by 3 and go boom. It doesn't work. I guess it. It just assumes that that's like the end of bracket. That's such a shame. Can I like add both of them? No. That's just sad. That is just sad. Alright, whatever. So this is 1s, 0, 0, 0, 1, 1, 0, 0, 0, yeah, yada, yada, yada. But my result is 5 minus 4, 1, 4 minus 3, 1, 6 minus 5, 2. And you know what? We are going to chuck that into a calculator. Actually. Matrix calculator. Yes please. Cause why not? How many questions are there again? I think there's like... Oh, we'll see. I'll check after. Yes, inverse. Oh, no, we can just do a 3 by 3. 3 by 3. No! Okay, let's try that again. 3 by 3. Oh, it automatically does the brackets. So smart. I forget. So it was 1, 1, minus 1. 2, 0, minus 1. 1, minus 2, 1. Yeah, try this. They got 2, 3, 4, minus 1, minus 2, 3, 1, 1, 2. What the heck? I got 1, 1, 2, but the other ones do not look right. What happened? I don't know what I did wrong. Why? Why? Did I enter the matrix in right? I hope so. 1, 0, minus 1, minus 1, minus 1, 1. Oh man. I don't want to check through all these steps again. This is why I should just use the cofactor method. It's too easy to make mistakes in row reductions. Locked content? Since when was this locked content? Dang, really? Hide steps. Locked content. So weird. Never knew that they had locked content. Man. Okay. I'm gonna check through my steps again. So these are the steps I used, right? So I'm gonna check through every single one of them again. Hella chaotic. Yes, any percent speedrun. Alright, R3 take R2. So that's... Did I already make a mistake? How do I get excuse me? Hello? Wait. Wait! Huh? What did I do? Am I crazy? scroll slightly up. Where? This one? This is the, just writing the matrix out. So it's this matrix that we're working with. Determinant doesn't matter right now. Wait! No, not right now. Right? Start at C. So this is our matrix. Ah, the first row of the matrix is off the screen. Gotcha. Okay, I'm gonna... What did I do here? I don't know what I did. R3 take R2. That should be -1. Wait, huh? Am I crazy? No, that's R3 take R1, isn't it? Yeah, 0 minus 3. 2. Okay, that's meant to be R1. R3 take R1 is here. Oh my goodness. It's the first step too. This is it's gonna mess with everything. Did I at least do the steps right after that? Cause maybe I just did the steps wrong on the right side matrix, right? And then everything else is okay. R3 take R1 is... No, I applied the wrong one. You're kidding me. You're kidding me. Alright, so this the bottom row is -1, 0, 1. Okay. You know, I want to just assume everything else is right so far, and then apply my other steps. No, you know what, I'd better check. Alright. And then you do R2 take R1 here. And that gives you... Yes, becomes R2, right? So that's 1, -1, 0, yeah. -1, 1, 0, yes, okay, that's fine. Cool. Cool. Then you do R1 take R2 becomes R1. So up to this step here. Tedious. 0, 2, -1. 2, -1, 0. You got -1, -1, 0, 0, -3, 2. Yep, okay. Cool. This is still -1, 0, 1 at the bottom. I assume that's our only mistake then, because if the right side is correct, it's because the right side was never changed. And the other ones are just slightly off. So this is going to make more sense now. 2R1 plus R3. So that's this one. Take 6. 4 take 3 is 1. -2 plus 2, 0. Yeah, okay, so 0, 1, 0. And then it's 2. So I'm going to have to fix that as well. I'm going to fix R1 now. 2R1 is 4 plus R3 is 3. Right, that's 3. 2R1 is -2. -2 plus 0 is -2. Yeah. Man, there's so many corrections to make if you mess up the first step. And then R3 should stay unchanged. I would have combined step 2 and step 3 into R2. Take 2R1. Becomes R2. So row 2, column 1 becomes 0 right away. Hold on, let me have a look at this. R2 take 2R1. Really? But if you do R2 take 2R1, you get row 2 column 1 becomes 0, but then... Oh wait, hold on. Oh. You'd get that, but then you'd also have to deal with residue in column 2, right? And column 3 then becomes 1, right? Oh, but if you have 1 there, it's best to do row reduction with a methodical approach. Turn the lower triangle to 0 step by step. Yeah, yeah. That's usually how we're taught. Oh, that is how we're taught, but I don't know why I didn't follow the process. No, that makes a lot of sense. Psh, it's too late now. I've already done most of the steps, so hopefully, like, from here on out, it's still okay. Because again, I think it's just the right side matrix that I messed up. It's okay. I'm sure there will be more reductions later in the, like, in later questions too, so it's not like this is gonna be over anytime soon, unfortunately. Row 3 column 2 minus 2. Yep, row 3 column 2 is minus 3. You do R3 take 3 over 2 R2. So you set row 3 column 2 is 0. Minus 2. Hold on, but you already have a minus 2 here, don't you? Row 2 column 2 becomes minus 2, yeah? Row 3 column 2 is minus 3. Did we modify row 3? Oh! Wait. Oh, okay, yeah, the previous step. Gotcha. Right, you set up the row 3 column 1, 0. Then you set up the 0 that's also in column 3. And then you do the upper triangle afterwards, right? Yeah. I completely forgot that. I was just like, here, let's brute force it, which is completely wrong. This is why I'm doing the practice. Alright. Just quickly, how many questions do I actually have? I forget. 7. If I have 7, it's not half an hour per question, even, which is rough. But I'm sure some of these are going to be easy, like, I'm sure. Sure, we'll be alright. We'll be okay. Alright, I'm typing stuff up and everything on the side as well, which means I'm taking longer than I would otherwise. So, that's okay, and I'm discussing, so if we take, like, an extra amount of time, I think it'll be okay. Thank you for that, though, Chaotic. You are absolutely right that I should do it methodically. If we take minus R1 plus R2. Can I trust my judgment there? Maybe. Minus R1 plus R2 is minus 4. Yeah, that's minus 4. And then this is 4 plus 1, which is 5. And then minus R1 is minus 1 there. Yeah. Oh, no, we're changing R1. Ooh. Oh my gosh, what am I doing? Oh, no, this is a row swap step. Whoa, where am I? I'm so lost. I lost myself. Okay, you know what? I'm just writing this on the right side now. So this is just a swap step, yeah, right? Yes, minus 1, 1, 0, 0, 1, 0, 0, minus 3, 2. Okay, so this becomes minus 1, 1, 0, 3, minus 2, 1, minus 1, 0, 1. Wish I could capture what I was doing at the moment. It would make it easier to understand me. Okay. Minus R1 plus R2 becomes R1 here, so we get... I'm sure the rest of the row reducing steps here are fine, so I'll just look at the right side matrix. Minus R1 plus R2 is... Maybe I should just write, yeah, everything on the right side rather than having to do extra, like having to rewrite everything. That seems too inconvenient, so I think I'll just do it again. Put down your current state every few steps so you can roll back if you're lost. Oh, yeah, I absolutely have been. Like, I write every step here, don't worry. I'm not losing myself. I leave little notes and everything. Yep, okay. Yeah, Minecraft, welcome. So that's 1, plus 3 is 4. Minus 1, take 2 is minus 3. 0 plus 1 is 1. Right? This one doesn't get changed. And then this one becomes 3r2 is 6. 9. 9 take 1 is 8. R3 is 0. There's minus 6 here. And 0 and 1 becomes 4. 4. Okay, and then it's final result 4, 3. 3 minus 2, 1, 1. This is probably still wrong, but whatever. We'll see. 4 minus 3, 2. This is completely off. I'm certain of it. I think as long as we know the process though, and like, if we did it properly, then I'm sure we'd get the right answer. And again, I'll probably use the cofactor method with this one anyway. I just wanted to try. I'm still off though. Oh, unfortunate. Two, 3, 4. I still got 1, 1, 2 on the right side. How do I keep getting that correct? how is it that my other 2 vectors are wrong? Or my other 2 columns are wrong? Man, maths is weird. How does that happen? This is so bizarre. It just remains constant. It's the one consistent thing in this world. What part was this? 1C. Alright. Every column of the matrix inverse is basically an independent problem. I suppose, yeah. Yeah, you're right. If you're performing the same steps, then it's a different problem. Which means that you'd only have to review the other 2 columns, regardless of what happens. Yeah, you're right, That makes sense now. That's very obvious. Man, okay, I'm just... So what I'll do is, I'll be like, this is not correct. Actually, reduces to 1, 0, 0, 0, 1, 0, 0, 0, 1, with the right side being 2, 3, 4, minus 1, minus 2, minus 3, and 1, 1, 2. Okay. Do you know how to solve a system of linear equations? A million times. We've been doing it all semester. I just made mistakes here and there. And so, kind of died. I mean, this is more by solving. that is the question, I suppose, in this case, yeah. It's funny. Okay, so this is just, I'm just gonna make this red. This is very bad. This is wrong. You're a meep. Yes, math stream pop. Just 1 column on the right. Oh, yeah. Like, when you augment it, right? Yeah. Or otherwise. Oh, is that what they mean by or otherwise, though? I mean, the lecture was going on about, like, oh yeah, what otherwise method would you use? And we were all stumped, and then I was like, oh, you can obviously just do it normally. Yeah, that's right. I could show my working out, I could take a picture and upload it, but that's gonna take too long. I'm not bothered. I just messed up a couple of calculations. So I got 112 at least. See, I did something right. Just not everything. Okay. Find the inverse, blah. Okay, so we're gonna state that the inverse is equals, we're gonna, do I have it in paste? I do not have it in paste. Can I do this correctly? Nice. This is 2, 3, 4, minus 1, minus 2, minus 3. What's with the timer? It's meant to be a timed exam. I'm gonna go over, but whatever. It's just practice anyway. That's our inverse. So, actually, not start that yet. D. Ax equals b. So, x equals, boom, amazing, right? So x equals this matrix multiplied by this one. Whee! Boom. I'm going to actually. Oh, it just says find x. You don't need to like explicitly write x1, x2, x3. So I'm sure just writing the matrix for it is gonna be fine. Oh, I'm gonna just make it so that it's 3 by 1. Okay. Whee. Actually, I probably have to write it anyway, just to show my working out. Drink some water before I get started on these calculations. Okay. Alright, let's go. 4 take 1 take 4 equals minus 1. 6 take 2 take 4 equals 0. What? x3 equals 8 take 3 take 8 is minus 3. So our final results are minus 1, 0, minus 3. And just to check that here, if we get minus 1, 0, minus 3, minus 1 plus 3 is 2, minus 1, minus 2 plus 3 is 1, and minus 1 take 3 is minus 4. So that's correct. Okay, we got the values for x correct. Nice. Awesome. Good stuff. Question 2. I also underlined it. I must do that. I must. Consistency is the essence. A to 2A. Sorry. Represent the system by an augmented matrix and perform one elementary row operation. Describe the row operation you performed in words or in appropriate notation. Write down the elementary matrix corresponding to this elementary operation. Okay, that's easy enough. This is 3 by 4. I can't write this in. Is there a way to actually? I'm curious if there is, but I don't know if there's actually a way for me to write this. Cause these are preset, right? You can't expand. So I might just have to do all of this by hand, which is a shame. You can right-click in the matrix. You can right-click in the matrix. Should have insert column. Ooh, okay, okay. Learning experience. Okay, so we're going to do this. I'm gonna insert. I never knew about right-clicking these. So you have what's professional linear. Save as new equation. Insert column after Oh! Chaotic! Thank you for saving me. Wow, okay, sorry. I didn't know. There you go. Incredible. Thank you for that. That actually helps so much. Now I can write big matrices. I have secret powers. And then also just one on this side. Amazing. Alright. We are going 1 minus 1. Minus 2. 4. 2, 1 minus 1, 5. Ooh! That's not right. 5. And then we have 0, 1, k. K squared take 2. I don't know why I wrote that in brackets. I don't need to write it in brackets. Magic of not drawing on Word. If I could draw, I could. Ah, it works out fine now. Okay, that's cool. It actually does the thing correctly. Describe the... hold on. Is there a value of k for which the system has a unique solution? Find any values of k where other cases for k equals 0 describe blah. We reference to the above, can vector be expressed? Okay, so that's this question. Alright, let's solve this question. We have to reproduce this whole thing, right? Eeeh. Oh, no. We don't have to in this case. We only have to... Okay. In this case, you would want to do R2 take R1, right? Because R2 take R1 becomes R2, right? Because then you get a 0 in left point. Hello, Tom. We are... we're timing speed, the speed of our exam prep, but maybe not speed running. I'm definitely not finishing the exam fast. It's a bit slow. Alright, so, we'll say 1 elementary operation. Okay, so, we're gonna write it anyway. Equal... Oh, not equal. Sorry, that's incorrect notation. Sorry, and this is 2R. 2R2. Is this connected? I don't know. Maybe I can do all my operations here. Yeah, okay. I can just be copy pasting my matrix. I don't need to do this. Oh, this is because of all the rows I had to deal with. Yeah, okay, fair. Probably a good idea. Maybe. Right. Cause then you don't need to rewrite everything too. You only have to modify like what you're changing. That's... I wonder if this is actually the pro move to make. This is 1 plus 2, which is 3. See, now you guys can see my calculations. Alright, great. Fantastic. Take 2. So minus 1 plus 4 is 3. And then 5 take 8 is minus 3. And then... that's 0. It's okay, maths is hard. So question B asks us what? Describe the row operation you performed in words or in an appropriate notation. Okay, so lecturer said this is fine because this is appropriate notation. How do you write down the elementary matrix correspond? You can't, right? That's actually a trick question, isn't it? It's not a square matrix. E1 cannot exist, right? Cannot exist as the matrix is not square. Right? Am I right in saying that? There's no corresponding E1 for it, right? I don't think so. I think I remember that being mentioned in the lecture as well. So I think I am right in saying that, but let me know if you have any conflicting thoughts. Is there a reason, or is there a value for k for which the system has a unique solution? No. There is not. Because there are 4 variables and only 3 equations. The elementary matrix exists. How do you write it? Because there are 4 variables and only 3 equations. Values of k for which the system has no solutions. If such values of k exist, you may want to do further operations to answer this. You may want to. Do I want to? I don't know about that. That's where the 6 marks is though, so definitely have to do. The values of k for which the system has no solutions. How much do we have to reduce? That's my question. Matrix E that when multiplied with your original matrix gives the matrix after row operation. Right, but usually you write it as... Oh, you can write it as a 3x3? Even if you have 4 columns? Like, that was my problem with it. I thought that it had to be a square matrix so you could represent it correctly, I guess. But oh, it's because you can multiply it? Oh, of course. Yes, you can, because the outer bit is 3. Yes, of course. I was thinking. No, okay. That makes sense. That makes sense. Yes, I was mixing it up where the inside ones have to be this. No, the outside ones have to be the same. No, the inside ones have to be the same though, because then your result is the outer ones. Yeah, 3x4. Okay, that makes sense. Thank you. E1 is then. No. Thank you for clearing that out. That helps a lot. Take 2R1, right? So it's -2, 1, 0. And then that's what you got as well? Cool. Thank you very much. Cool. Dark screen? Dark screen? I hope it's not. Seems okay to me. What is this? That was from earlier. We don't need that. It was for a bit before you read that? That's weird. I wonder what happened. So we require R3. 3R3 take R2, yeah? So we have this matrix. Right. And then you do that way. Ooh. Stink. LU matrix corresponding to this. This is the identity matrix having as many rows and columns as the number of equations. Except. Wait. Right, I see. I see. Right. I think that makes sense. I hope it makes sense to me. I believe that's a step you take, right? Because then from here you can deduce what values of k make these 0, and then you get the no solutions. Oh, there we go. Wikipedia article. Right. I think even the lecturer got confused about this though. I swear she was saying like, oh, you can't do it because it's not square, but maybe she didn't realize either. Gotta be careful of that. I hope she doesn't mark me down though. What if she doesn't realize it by the time the exam comes around? I'll have to rewatch the lecture to double check if she mentioned anything about it, but I hope there's no issue. So this is 0. This is 3k, take 3, and this is, oh, this is big. Oh, no, it's no problem, because it's just 3k squared. Take 6, take 3, right? Plus 3, so that's 3k, take 3k squared, take 3. Yep. And then the bottom one is minus 18. Yep, minus 18. Okay, I think that's good. Now we can deduce that from when, oh, that's, no. When k equals 1, the bottom row becomes can you like highlight a row, I wonder? No, it's okay. It's okay, I have the power of no. Ah, that's why I wasn't in the insert column after. If I highlight 2, can I do it 2 at a time, like with a table, where you do 2 at a time? No, it won't even. Oh, I guess that you can double dark screen again. Why is it dark screening? Oh, that's why. Okay, I understand now. I figured it out. Hotkeys. Switch to scene, right? I use this usually for like the Puyoverse streams, but even then I don't use it. We don't use Puyoverse anymore. So I actually don't need these hotkeys anymore. Where's the other one? Hold on. It was earlier, right? Or there it is. Oof. There you go. So now whenever I use square brackets, you would not get dark screen. I understand now. Alright, bottom row becomes 0, 0. Oh, let's add another. Insert after 0, 0. Minus 18. And hence there are no equations. No, no solutions. Hold on. What exactly was it asking? Maybe I can answer with the same. Hence, yeah. the system has no solutions. There's no solutions. Is that all the reasoning I need? For k equals 0, describe the set of solutions to the system using parameters as necessary. Okay. The wording of the problem is a bit weird. Do you think so? I think that sounds fine. Is there a value of k for which the system equations is... Oh, no. Find any k for which the system has no solutions, right? And this is the value of k, right? K equals 1, right? If such values of k exist, then yeah, it does in this case. Oh, hold on. These are two different questions. Oh, no, this is... I'm so lost. Wait, where do you explain? Oh, this is explain. Oh, sorry. No, there is no explain in this one. This one is just do the maths. Right, okay. That's why. Find any value of k. So I guess you don't need to mention whether k equals 1 is the only value that gives no solution. Oh! Oh, no. I think it means... It should be the. Then yeah, you're right actually. Find the value or the values for which the system has no solutions. I guess it's not being as specific as that. You're right actually. Find all values. Yeah, I'm not sure. I'd assume it's just an oversight, but like considering it's 6 marks as well. If there was any extra step, it would be implied, I suppose. Oh, you need to show k equals 1 is that essential? I think it's fine. I think for our level, like just deducing that this is the result is fine. I think you would think so, right? Is that so? I never even thought to like think about doing such a thing, but I understand what you mean by the confusion in the wording of that question. That's fair. Okay, so k equals 0. Let's rewrite this matrix with k equals 0. Oh, not that one. Oh, no, this one's probably simple. Yeah, because before we did anything crazy. Oh wait, is the original matrix even simpler? Hold on. No, this one's simpler. Yeah. You have like 1 and minus 2. Wait, this is the same, yeah? Okay, I'm not crazy. So this is 0, and this is minus 2. Okay. Do we want to reduce further, or can we even? I don't know. You know what? I think I'm just gonna write these as the equations. Take x2, because we can just set up our free variables, and then from there we'll just work on it. Plus 4x4. Ooh, 4x4 equals 2. 3x3 plus 3. No, there's too many 3's here. Oh, we can just set this to be 1, 1, minus 1, right? The equation for E, the question for E. For k equals 0, describe the set of solutions to the system using parameters as necessary. This one we can divide out, yeah? So, that'll just make it easier to rewrite. Oh man, this is 2. x3 take x4 equals 0. Right, that's logical. Oh, you can continue from D? Oh, I suppose so, but that... Oh, because then you get -3, -3, right? -3, -3, -18. Oh, you're right. In that case, that's not going to take much modification anyway. Yeah, this will be -18. I can also just divide out by 3 here too, hey. Oh, -3 even, so that's x3 plus x4. Actually, yeah, this is easy to work with now. Equals 6, yeah? Yeah, divide those out by 3. We can divide by -3 in this case as well, which is really nice, actually. And then from here... Can we set one of these to be... No, hold on. Hold on. Oops. Right, reduce it further, because I was like, this is harder to work with now, right? I'll type this down, because it'll probably look similar afterwards. Right, and then we can use... Would we remove the rightmost column here? Or the one in the middle? Does it really matter? Hold on, let me rewrite this with the reduced forms. 1, 1, -1. This will be easier to interpret. 8. Oh wait, alright, my steps here. I'll just... we know what we're doing. Row 2, column 3? Gotcha. Oh, because then that gives us our, like, line here, right? Yeah, gotcha. Oh, and yeah. Then you reduce these as well, don't you? Yeah, row 1, column 2, and column 3. Gotcha. And then this it's because this variable you just leave out. Yeah, okay, gotcha. Because then you can determine the linear independence here. Like the 1-on-1s, the pivots. Okay, let's... Yeah. Gotcha. Cool. Let's do this. Okay, you know what? Maybe we'll write my steps. So here we're going to do... R2 plus R3 becomes R3. Oh, no. I copied the wrong matrix. Oh, I didn't have this copied, that's why. No wonder. Yeah, okay. This will be cleaner. 0 plus minus... No. No, yeah, we're subtracting now because we already... Gotcha. Man, I'm not copying the right matrix over. I need to recopy every time. Okay, so this is now... No, R2. Man. It's okay, we got this. We're fine. 0, and this is -2. 0 takes 6 is -6. Incredible. Right? Cool. Next. R1 plus R2 becomes R1. copy this one. Thank goodness for that. 0 minus 2. Oh, yeah, the same's the same. 4 take 2 is 2. 2 minus 6 is minus 4. Have I been making sure this right side is also getting affected correctly though? Let me just double check that. Did I copy this 2 times? No wonder I was so lost. Hold on. 1 1 minus 1 0. 1 1 6. Okay. Yes. Yes. And yes, of course. Cool. Good one. 1 take 2 2 R2. Oh, plus R2. 2 R2. Sorry. 3 becomes 1 now. I think I will be confident doing the exam without having to scan stuff in then at this rate. It's good. Mock exam solutions. With overwhelming emails demanding for the solutions of the mock exam, I decided to write them up this morning. The solutions are up there now. Aww. I decided to write them up this morning. Aww. Thank you. This is the, I don't think we have solutions for these ones, but I think she went through some of these questions during the, during one of the lectures, which is why I remember catching it at some point. Like, I just don't remember. I know that she did them, and I was sitting there for the lecture for like revisions to take it in, but now I'm just doing it as well. Overwhelming demand. It's so intense. It sounds like we pressured her into it. I'm like, please, no. Alright. She's a really good lecturer though. She's really good. A lot better than some of my other ones. Oh, this one other one is... okay, anyway. We'll get there when we get to that subject. R1 plus 2, R3... Did I do this stuff? No, I did not yet. So this is 0 now. Hooray! So that's 2 plus 2 is 4. And... minus 4 plus 12 is 8. Cool. Now... do I have music playing? Did it like stop? What happened? I hope it's okay. There it is. X2 take 2 x4 is minus 6. X3 plus x4 equals 6. Okay, how do we write this again? Right, wouldn't we end up with 2 vectors? If I write it like that? Or, no. That's fine, isn't it? Because if you write this as t, then your equations then become this 8 take. You have constant take. Oh, but then you don't worry about the constant, right? Because it's spanning anyway. Yeah, because you're spanning that space. The constant vector doesn't matter, does it? Yes, of course. Oh, it's not asking for a basis though, right? It's asking for a set of solutions. Oh, so you can just say this is a set of solutions, right? Because you don't even need to write it as a as vectors. Right? Set of solutions to the system. Then x1 equals 8 tick 4 2 minus 6 plus 2 2. And yep, okay, cool. Yeah, I was confused because usually they ask for like the basis for the thing, and I was like, oh, then you do, because then it would just be, oh, this is wrong. It would just be minus 4 2 minus 1, yeah. The set of solutions is, yeah, and that's for x1, x2, x3, x4. Yep. For all real t. Should I state that? I think they... I'll remember. With reference to above, can vector 2, 4, minus 6 be expressed as a linear combination of the vectors these? Explain your answer. Oh, this is also... Hold on. Oh, no, that would be minus 4. Gotcha, okay. If t is... What is it? 12? No. No, hold on. Oh, minus 6. Hold on. 2. Oh, 2, 4, minus 6 is the right side of this. Can vector 2, 4, minus 6 be expressed as a linear combination of vectors? If you find a solution, regardless of whether it's with reference to parameters or not, then it would mean that you can get to it through a linear combination of these vectors, right? Oh yeah, of course, right? Because these first three vectors are linearly independent, right? Which means that you can also say that, right? So that you can reach any point in the plane, regardless. Right. As in question 4. Hold on. This point distribution. Ah, no, it's not. Wait. Dang, wait a minute. Oh, I guess this is extra steps, right? Because you could always set the parameter like early on, right? And they would just do some rearranging. I was like, this is 2 marks. Finding a solution is expressing 2, 4, minus 6 as a linear combination of vectors. Gotcha. As in question 9. Ah, hold on. What your system says is x1 times 1, 2, 0, x2 minus 1, 1, 1, blah is 2, 4, minus 6. Gotcha, gotcha. Even if expressed by a parameter. What was I putting in here? This. It is true that. Ah, whatever. Question 3. Show vectors are linearly independent. Hey, if this was only 6 questions, we'd be. To be fair, question. I don't know. It's probably harder than it looks, but it doesn't look long. We're halfway through the questions, right? No. that would be if we had 4 questions. I can't do basic maths. Oh, hold on. I meant to turn that one down. So it's, yeah. It's okay. We'll be fine. It's all practice. Show that vectors blah and blah are linearly independent in R3. Show that? I must be feeling really tired right now. All of the definitions are going over my head at the moment. It's not good. Let's hope it doesn't on Monday. What are these questions? Exam style questions, right? This is the 2019 exam. So well, you can just say that V1 is not a scalar multiple of V2, right? So they are linearly independent. That's 3 marks though, and these are 2 marks. Is that all you have to say? That's right, isn't it? V1. Oh, that's nice. Is not a scalar multiple of V2. As such, they are linearly independent. Oh, that was... They are linearly independent. I think that's right. The Graham-Smith process to find an orthogonal basis for this. Do I want to? I don't really want to. Let's set W1 equals 101. Let's copy this so I can just have a thing to work with. 1, 0, 1. W2 equal. Oh, I don't remember this formula. Is it? I'm trying to remember it just off the top of my head. It's W1. Oh, I can. No, it's stop for that. So. Right over W2. Is that right? Wait. Oh, look through my notes again. But if anyone remembers or knows, you can feel free to let me know. Is it in my other book? Oh, it's probably my other book, isn't it? Yeah, the Graham Smith was early on in the course. Let me see. That is the first problem solving exercise. Linear transformations, vectors, linear transformations, integration. That's the wrong subject. What page did I do it on? It's here somewhere. Ah, it's W. Wait. No, it's W1 out the front, isn't it? Yes, it is. It's W1 for all of these. And W2 at the... I don't remember now. Where is the... Where is my, like, notes for the actual... Oh my gosh. This is me doing the process, right? Where is the actual formula? Am I blind? I'm not blind. Maybe I never wrote the formula down. That would be a bit of a problem. I have the lecture notes up too, so I can look at that, but I was just wondering if I could like find it in my notes, because that would be useful too. Also, yeah, I don't know what I did to it. Yeah, whatever. I'll look at the notes. It won't be hard to find anyway. I'm just lazy. It's not even laziness. I don't even know what this is. It's not reason. What's up? How's it going? Let's look at gram. Great. How many grams could there really be? Yay! The formula! It's literally just this. Here's someone. Wait, hold on. Where is the formula? Where is, like, basic formula? I don't want yucky, scary looking formula. Oh, it's this one, right? Yeah. VK, take VK, WJ, the following. Okay, I know now. Yucky. So it's 210, yeah? So this is, hold on. It's V2, take, and then V2 here and W1 there, right? V2. And this is W1. Of course. I want to be W2. W2 is the result. Alright, that's the delicious thing that we're looking at, isn't it? I think I'm right. Pretty sure that's correct. And then So yeah, we're finding W2 for this. V2 is vector 2, 1, 0, right? 2, 1, 0. No, let me highlight. 2, 1, 0. 2, 1, 0. Take. Blah over this. So V2 dot W1. Oh, so this is dot of these two anyway. Considering using the same vector. So it's 2, 0, 0, so this is 2. And then W1 and W1, so that's just this with itself, which is 2. Right? And then the vector that we're... Oh, it's just this one. And this is just 1, right? So you get 2 take 1 is 1. 1 take 0 is 1. And 0 take 1 is minus 1. Oh my gosh, I just deleted everything. Right? 1 take 1. 1 take... Yeah, 1. No, 1 take 1 is 0. Did I say that? I hope I said that. That's right, isn't it? I'm doubting myself now. No! It's 0 take 1 is minus 1. Yes, I was right. Oh my gosh. I can't do maths. Okay, so that is... Yes, the orthogonal basis is 1, 0, 1, and then you have 1, 1, minus 1. And then that's curly bracket. Boom. That looks right to me. Describe the orthogonal subspace in terms of vectors blah and blah. What is the dimension of blah? Orthogonal subspace V cup is... I think this was an assignment question actually. She just wanted it written in words. The subspace, which is orthogonal to both V1 and V2. That's orthogonal to both V... Hold on, does that make sense? I don't know if wording it like that makes sense. Dimension of V is what is it? 3? Hold on. What is the mini formula for this? It's like n, so 3 take 2. Can I just say it's 3 take 2 is what? Do I need to explain what 3 and 2 are? I think that's fine. Find a basis for the thingy. Find this case. Let the basis be we have this times v3 and this times v3 should, right? Hold on. We'll let v3 equals 0 and v2 v3 equals 0 where hold on, where v3 equals, do I have it copied? Yeah. We'll just denote these x, y, z. It's whatever. Oh, I did not need the extra bracket. So x plus z equals 0. Plus y equals 0. Let x equal, no, not let like that. Eee. Let x equal to, then z equals minus t, y equals minus 2t. As such, the basis for v up is bracket, open this, and it is 1 minus 2 minus 1, 1 minus 2 minus 1. Yeah. Boom! I think I did that question right. I think that's good, right? I hope so. Hey, we're not even that far behind. That question only took like 10 minutes. Right? Oh, not bad. Not bad at all. Question 4. Have I been putting... Oh, I did it for question 2. Oh, the end. Alright. Okay. Hello Andy. Never learned how to depict vectors in some matrix. So good. Doesn't really matter too much. So I think this is right, yeah? If we just take dot product with each of them, it should be right anyway. Right, just to double check. 1, yeah, obviously is 0. 2 and minus 1 is, minus 2 is 0, yeah, okay, wonderful. that is obvious. Consider matrix blah. Clearly, yes, is an eigenvalue of A. Show that is the only eigenvalue. Show that it is the only eigenvalue. Show that it is the eigenvalue. That's 2 marks. I figured you would have to like find the eigenvalues and show that it's... I guess it wouldn't take like that. You would think it would be 3 marks. Because I figured you can show A take lambda I is blah. Oh no, it wouldn't be hard. Okay. I equals. And then let's get up this matrix. Alright, so this is 2 take. This is the same for all. 1, 0, 0, 0, 0, 0. The values are wait, but everything's 0, isn't it? Oh, hold on. To take oh, not I. And then this little matrix here, right? Because we go here, and then I've got it pasted right now. And then it's take 0, yeah? Because clearly these are 0, and clearly this is 0, right? Right, like this is 6 0 plus 0, right? I don't think I need to elaborate on that. I don't know if there's a faster way to show this, because it's only 2 marks. It's easy to show, but like it just feels weird. Right? Equals this, right? That 0 from this. This 2 is a solution. As such, 2 is the only eigenvalue. That's the only way I can think of showing this. Inverted matrix at third diagonal. Wait. How to get the inverse matrix at third diagonal? What do you mean by that? I think that shows it proficiently. I'll check again in the lecture if that's how she does it then, or maybe not. We'll see. Find 2 linearly independent eigenvectors of A and show that A does not have 3 linearly independent eigenvectors. Can you find the eigenvectors again? This one for sure I wrote down. Here we go. It's right here. Hold on. Right, you sub in the value for A take 2, 2i equals. Is this but messed up? Yeah. 0. Right. And then you go the kernel is given by x2 equals 0, x3, x1 is equal to t. So x3 has to be negative t, right? No? No, that's not right, is it? Because then you get 1, 0, minus 1. That's only one eigenvector. It's the other one. Is that right or is that wrong? Alright. Third square matrix. Wait, inverted matrix at the third square matrix? I'm still rather confused. Isn't there something keep— oh, sorry, this should be S3. Oh, not necessarily, right? Because that implies that one. Sorry, I gotcha. This can just be S, right? You would just say it's S. The thing is, it's not 1. It's not 1 and 1, right? So it's not t and negative t. It's 0 and 0. Right, so then— doesn't that mean it has to be 0? No, it doesn't have to be 0, though. Because in these solutions, it can be anything. But in this one— oh! No. No. No, that's not— huh. Is it right to be saying that x equals 0? Yo, thank you for the host. I can't check who it is, apparently it didn't come up, but very much appreciated. Thank you. No, this is not right. Right? Hold on. So, eigenvectors are found by finding the kernel of this, right? And so that means you're only— you get 0x1 plus 2x1, oh, 1x1 plus 0x3, right? And if you set them as S and T, and they're all 0 here, what does that even mean? I don't know. I guess they just don't matter, right? They just don't matter. It's doing my head in, but I'm sure that's right. Okay, so as such, the two linearly independent eigen vectors are, and then you just write them as of a what do I have copied in right now? No. Let's go ahead and this one. So you get 0 set here, but then you have 1 here and 0. And then you also have this bar with 1 down here, right? And those are the linearly independent eigenvectors, right? Cool. However, how do you show that A does not have 3 linearly independent eigenvectors? How do you show that? Is it something to do with the multiplicity of 2? Being like 3, so it's like, oh, you can only get 2. I don't know. I don't know what is that. I don't know what. How do you show that there's a... Is it just because, oh look, dimension of the kernel is 2, so there are only 2 linear, like, the, since... Hold on, is this the third part of the question? Oh, hello. Since... Right? Since the kernel is 2 and was 2 is the only eigenvalue. It can only be 2 linearly independent eigenvectors. Vectors. Right? I don't know if that's right or not, but whatever. You're a Kairos? Welcome. Still in pre-calc? Nice. Pre-calc. Early calc? Very fun. Calculus is still fun for me. I'm still enjoying calculus. But that's probably tomorrow. It's probably what I will study tomorrow. Probably spend today for linear algebra, tomorrow for calculus. And then... in between... I could probably do some more calculus. Oh, maybe I'll do some more linear algebra tomorrow as well. And some more calculus. And then on Monday I can also study calculus. When I'm not... like after my linear algebra exam, I can do my calc study. And then Tuesday and Wednesday I should spend on my object-oriented programming, I guess. So much to think about. I'm planning it out. Because then that gives me 1.5 days, 1.5 days, and then 2 days. That sounds reasonable to me. I think that's okay. Yeah. Cool. I don't know if that's like an okay explanation, but sure. No, don't want you to capitalize it. Thank you. No, A is not diagonal. I always forget how to diagonalizable. Diagonalizable because there are insufficient linearly independent eigenvectors. But I can't type right now. Okay. B. Suppose that A, an n by n matrix, is diagonalizable. That is, there exists an invertible matrix P such that blah, where D is a diagonal matrix. Prove that for integer k is more than or equal to 1, the following. The heck? What? So, hold on. Let me digest this. Suppose that A an n by n matrix is diagonalizable, that there exists an invertible matrix P such that P inverse AP equals D, and D is a diagonal matrix. Prove that for integer k is greater or equal to 1. Are we just rearranging to get... No. How do you get A to the k? Haha. First you want to isolate. Oh, we can find a pattern, right? You could start with like A1, A2, and then just move up from there. I think so. Okay, hold on. So this is... Oh man. P minus 1. AP equals D. Okay, okay, yes, I think this is fine. For k equals 1. A equals P, just P. P, D, P. Yeah, right? For k equals 2. A squared equals P. Oh, yes! Okay, gotcha, gotcha, gotcha. Got it. Found it. I know how this works now. Times P, D, P, minus 1, yeah? And then you get P, D, I, dp minus 1 equals P, D squared, P, minus 1. Okay? And then, just copy the process. For k equals 3. It's the same thing. Okay, and you just see the pattern follows through. Right? So, as a result, AK equals PD to the K P minus 1. Right? I think that's sufficient. I think that's sufficient, right? Looks right to me. I think it's okay. I hope it's okay. Cool, and now we are on pace, right? Well, on pace for like if there was 6 questions. And again, this might be okay, so it's interesting. Alright, consider the following system of first-order ordinary differential equations. Write the system in the form blah blah. Okay, that's easy. This is the easy part. This is the 3 marks part. Question 5. Good to see that we're up to 5. Alright, part A. Okay, so we're gonna... This is matrix blah... Hold on, let me draw the brackets first. Draw. Type. So this is... X 2 dash, X 3 dash. Okay, and that's fine, right? And it's AX. Okay, so the next one is hold on, bracket. This is a 3x3 matrix. Whee! This one is this one. Whee! X2, X3. Our matrix is 2, 1, 1, 1, 1, 1, 1. 2, 1, 1, 1, 1, 1, 1. No, I got it wrong. It's the other way around. No, too many ones. I'm very good. What? I am very efficient. Could just use my mouse. 1, 1, 0 is 1, 0, 1, blah blah. Poof. Boom. Congratulations. Awesome. That is literally it. Find the eigenvalues and eigenvectors of the matrix A. Okay. This equals the following. Whee! I'm just gonna copy this. Boom. Boom. And people said digitally is slower. Look at this. It's so efficient. Love copy paste. Right. Debt. May take. Look. Oosh. There we go. Do we have to write all the stuff? I guess we'd have to. It's just right to write all the steps. Oh, no! No, don't load some more stuff. I don't want. No, thanks. And we'll make this a 2x2. Let's copy this over as well. Take 1, this, plus 1, this. Alright, we're gonna copy this where we need to. This goes here, this goes here, this goes here, and this goes here. This goes here, this goes here. Right. Copy pasting ones. So efficient. See, look at that. So speedy. Anyway. Yeah, right. Writing all that down would have taken a while. We are pros. So let's copy this again. This is gonna be tedious through. Squared. Take. Oh, it's just one take. Because this one's 0. Plus, what is it? Minus, actually. This ends up being minus, because this one's 0, and then you subtract. Oh, but then it's just, I'm gonna take 1 instead, right? Okay. And then you simplify it. Oh, jeez. Do I have to expand this all out? Oh no, I can write them all as... Oh, never mind. Smart time. Boom, right, and then you get equals 2 take, right, and then it's 2 take, take 1, boom, and then it's 1 take. Oh, it's more than that as well. Actually, it's you also have to have 1 take, right? Hold on. Let me know if I'm mathing wrong. Is this right? Hold on. Oh, no. You do it here and then you just take that, right? 1 take. No, I'm doing this wrong. Okay, so like, what if this was just x, right? That's x squared. Take x, take x. Then you keep an x inside. Ah, yeah, that's right. You're taking out... You're taking in the x. So let's just backspace a little bit. Okay, that's right. Except this one, that goes away. We just do 1 take lumber, right? And then this one comes inside. Right? So then you get this times x, take x, take x. So it's take 1, take 1, take... Yeah, cool. Good. That's good. And then we simplify this. We get number squared. Take 3, plus 2, take 2, which is 0. Nice enough. Okay, and then final step. This, take 3, 1 take. Yeah? Yeah, there you go. Right, and that works out just fine, I believe. Right, so my logic here is correct. You group by. Let's go. No, that's over. No more thinking about that. Take 1, yes? 1 take lumber, yes, because that's the factor. You get s squared, take 3, plus 2, take 2, 0, 1 take, and then factor out. Cool. Hello, Adama. Are we doing linear algebra today? We are indeed doing that. Welcome to the stream. How's it going? Do you happen to have experience? It seems like a fair amount of people have experience. I suppose for many of you guys do like IT stuff, right? Which requires linear algebra, from what I know. So yeah, there you go. Everyone's smart. So what did it want us to do again? Find the eigenvalues. The eigenvalues are 0, 1, 3. Oh, now we need to find the eigenvectors. Oh, it's 8 marks for this question though, so all the work makes sense. It's fine. 4 equals 0. My degree is in CS, terms of linear algebra needed. Ah yes, CS. That sounds about right. Oh, that means you're very good at it. Nice. Very epic. What am I doing? Right, I'm doing... Oh. Whatever, I'll write it for clarity's sake. And then this is... No, what am I thinking? I copied lambda already, okay. A takes 0. And that gives us the original A vector, which is this... Oh, matrix, sorry. Matrix. And then... we have to solve that, don't we? That's poopy. I don't want to. Right? Do you have to solve for each of these? You have to solve for each of these, don't you? If you have a 3x3, then you have a lot more. Eesh. Alright, I guess we're gonna reduce this. To take R1 is... No, it's R3. Right. This is now this. R2 take R3. 0, 1, minus 1, right? Okay. Hold on. Yeah. This will give us a cleaner result. 3! This is 3. I cannot count. You may or may not have realized, but I cannot count. I also need to modify this. Yeah. 0, 1. Right, so R1, take 2, oh, yeah, so that's 1. It's 1, take 2 is minus 1, right? Oh, I see. There you go. That's where we have R2 take. R3 is, becomes R3, and we rewrite this matrix with zeros. Right? We can also... Oh no, at this point we don't need to worry about it. Right? Okay, so 2x1 plus x2 plus x3 equals 0. And x2 take x3. Take x3, I said, equals 0. As such, x2 equals x3. Let x3 equal t. Then x2 equals t. Now, 2x2 plus t equals 0. So, which gives, okay, 2x2 equals minus 2t. From this, x2 equals 1. No, it equals minus t. Right? I think that's right. Whee! Okay, I'm gonna finish this question. And, oh, I don't know if I can finish this question. I'm gonna have to halt it because I have to get going. But I'll finish this off when I get back, I think. Welcome back, Chaotic. Welcome back. I'm just doing more solving. Typical, right? Okay. The eigenvector. Oh. As such, I don't know. Do I usually have a? Oh, I just call it V1, V1, V2. The eigenvector, vector. Which one is this? This is question number 5. It's differential equations. We've done this. We're finding the eigenvalues and eigenvectors of the matrix A. So, I'm currently in the process of doing it for eigenvector for eigenvalue 0, which is fun. This means we get 1 minus 1, 1? Is there somewhere I can copy, like... I'm so lazy. Whoosh. Whoosh. 1 minus 1, 1. Oh! No. Hold on. Huh? Where did I get 2x? Good thing I spotted that, because that would have been very bad. x1 is minus 1. So this is minus 1 here. Okay. Oh, now I have to do it for blah equals. Yeah, I'll finish this part and then I'll pause timer and come back in, I think, like maybe 2.5 hours. Because I've got to get going. I need a break anyway. I mean, I don't know in an exam you don't get a break, but shh. For studying, it's okay. Because I'm going to time it. I'm going to keep it timed. Right, okay, just finding the next one. 2, right? Is the next one 2? Or is it 1? What am I eigen... 1. 1, okay. So this equals 1. Let's do this. Because this is the matrix for 0 anyway, so you just subtract by 1. Take blah. Okay. Oh, wait, no, what am I doing? Hold on. No, you subtract 1 from each of these. Sorry. I'm being silly. Oh, and you can just... This is also fine. I didn't know you could even solve a system of differential equations like that. Yeah, you use a formula to write a solution. It's very... It's not elegant, but it works. So, yeah. We're just going to work on this. Anyway, I hope I did that right. Right? Hold on, I'm just going to look at this. So you get 1, 0, 0. Yeah, okay, sure. Fine, whatever. So this leaves you with x1 plus x2 plus x3 equals 0 and x1 equals 0, right? So then you get let x2 equal t, then x3 equals minus t. As such, yeah, that's okay. This one was easier as well. V2 is 0, 1, minus 1. Yep. Let. No, not let. 4. 4. Yeah. Lambda equals 3. I'm gonna copy this matrix again. Oh, it's 3i. Yeah, no wonder I was just... Yeah. Because lambda is the value we're replacing. Duh. Okay. It's pretty elegant and very efficient to code it as an elegant if you get into programming. Oh. Okay. If you say so, then I can believe you. It just looks so messy and I'm like... I mean, it works. That's kind of my response. So it's like, yes, this works. It doesn't look pretty though. But if it's efficiency code, there you go. Alright. That's cool. I'm doing just maths. I know that next year I'm going to be the one programming thing that I have to do is linear programming and networks is the name of the course. No idea what that's going to entail, but considering what you're saying, it'll help when I get there. A take 3i is then this, but you subtract 3, so it's -1, -2, and -2. Yeah? Okay. Alright, we're going to reduce this one as well. It's no problem. R2 take R3 for R3. We're going to copy this matrix over. So that's 0, -2, and 2. Yeah? Then you get R1 plus R2 becomes R2. R3, sorry. I don't know why I get these numbers mixed up so much. Oh, sorry, this is the wrong matrix. Copy this one. 0, 1, -1, right? And then 2 plus R3 becomes R3. And then let's copy this matrix again. You get 0, 2 plus take 2, 0. Ah, there you go. Did not even realize. And then that gives us the values x1 plus x2 plus x3 equals 0. And minus x2 plus x3 equals 0. Here you can set let x2 equal t, then x3 equals t. Now, minus x1 plus 2t equals 0, so x1 equals minus 2t. Right, and then this is minus 2, 1, 1. And that is our 3 eigenvectors completed. In summary. Because I want to group everything together. And the corresponding eigenvectors are where's V2? And alright, and that's gonna do it for now. How do I pause timer? I forgot my hotkey for pausing. Settings. Do I have a pause? I don't have a pause. Can I manually pause? I can manually pause, right? Hold on. I don't. Oh dear. I'm just gonna set like this one. Boom. No, didn't work. Oh, please work. What? Did I not pause? Okay. There you go. Nice. Alright. I'm going to keep it there now. Thank you all for joining me for now. I'm going to be back, as I said, in like 2.5 hours probably. So if you're around for that, cool. If not, that's okay too. Is V1 orthogonal to V3? I don't think so, right? Oh no, I'm gonna have to check everything when I get back, but that's gonna be it for now. I'll finish the exam when I get back. Yeah, thank you all for hanging out. It's been good. probably do another one of these tomorrow as well, if not tonight. Well, tonight will be linear algebra, but tomorrow I'll probably do a bit more linear algebra, and then I'll go ahead and do some calculus as well. So I'll be there for that. They should be? Oh, they should be? Okay, we'll have a look at that after then. Alright, I'll see you guys around. Thanks for hanging out again. As always, hope you all have a good rest of the day, alright? I love you guys, and I'll see you all next time. Bye-bye for now. -1 should be. Alright, I'll have a look at that. Thank you.